Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about decision making. This topic is based on a tech blog with the title Collective Decision Making with AHP, written by the engineering team from New York Times. You can find the blog link in this episode's description. Throughout this episode, we will dissect the topic from both business and technical angles. Now, let's dive in. On the business side, the problem solved is about making good decisions. Speaking of decision making, we all make decisions on a daily basis. We decide on both small matters, like where to have lunch, and significant ones, like which college to attend. We, as individuals, are the sole stakeholders and need to carefully consider our choices. However, if the decision need to be made at the team level or company level, there are many more stakeholders involved. So, decision making requires a much more alignment across people and is usually more challenging. In the context of this tech blog, the New York Times identity team is responsible for building and maintaining identity and authentication services for all their users. They have started an ambitious project to build a centralized identity platform. There needs to be a lot of decisions, such as what languages they should use, what database, and how can they best protect personal information. And there is much more questions like this. These decisions often impact multiple teams. So, getting collective alignment on the decision is critical for the project success. Now that we've understood the business problem to solve, let's shift gear and dive into the technical side to see what could be a good solution. Let's first consider a status quo approach to drive decision alignment. The team could make a proposal about why they think a specific solution is preferable. They can state the trade-offs considered and share it with others to align. However, others may challenge the decision on those specific trade-offs made, can challenge on the factors that may or may not include in this consideration, and also can challenge whether that's all the trade-offs need to be considered. This might be too conceptual, so let's take a simple example to illustrate. Let's say I want to buy a car, an SUV, for my family, and I propose to purchase a Lexus RX 350, a good SUV, and I state it's comfortable and reliable. However, in this example, there are multiple ways this decision can get challenged. My family may question, why are comfort and reliability the top priority? Wouldn't it be nice to spend less on a car, like buying a Toyota Camry, which is very reliable, yet requires much less budget? They can also question on which factors should be given more weight, comfort or reliability. If comfort is prioritized, why not choose the Porsche? Even if we settle on comfort and reliability, people may ask, why choose a Lexus over a Mercedes-Benz or BMW? Is there any evidence that Lexus is better in terms of comfortable or reliable? As you can see, for such simple examples as buying a car, there could be numerous areas where people disagree. And if the stake for decision is higher, like making a privacy design choice that could impact the whole company and many other teams, it could be a daunting task to simply make a proposal and strive for alignment. Without a solid analytical framework, it is very likely that people are not aligned on the final decision, resulting in either unnecessary escalation or suboptimal compromises being made without full judgment. Seeing the above example and knowing the challenges, let's take a look at the team's proposed solution: Analytical Hierarchy Processing. The Analytical Hierarchy Processing, or AHP in short, is a method for organizing and analyzing complex decisions using math and psychology. It was developed in the 1970s and has been refined since then. AHP is targeted at group decision making and is used for decision situations in fields like government, business, industry, healthcare, and education. Rather than prescribing a correct decision, AHP helps decision makers find the decision that best suits their goal and their understanding of the problem. It provides a comprehensive and rational framework for structuring a decision problem, representing and quantifying its elements, relating those elements to the overall goals, and evaluating alternative solutions. The AHP generally involves the following steps. Let's take the example of purchasing a new SUV for my family to go through this. Step 1 is to construct the hierarchy. In the car purchasing example, the hierarchy is that my family considers 4 criteria: cost, safety, comfort, and reliability. I could further divide those criteria into each sub-criteria, but for simplicity, I will stick with the 4 criteria here. Given these 4 criteria, I have a few cars in mind as alternatives. Let's say it is Lexus, Mercedes, Toyota, Porsche, and BMW. For simplicity, I'll just use the brand name, assuming they are most popular SUV cars, like BMW X3, as the example. Step 2 is to make pairwise comparisons for the criteria with respect to the goal. Let's say we need to decide which criteria is getting a higher weight or higher importance, such as, is cost the deciding factor, or whether comfort is a key. It is very hard to just assign them a weight directly, so the process requires pairwise comparison. AHP will ask questions like, how is cost compared against safety? Based on my family's experience, they may agree that safety is moderately more important than the cost. Then we will know that safety is slightly higher important than cost. Through all the pairwise comparisons between all the criteria against each other, AHP can calculate a consensus weighting among all the criteria. Step 3 is to make pairwise comparisons of the alternatives with respect to the criteria. For example, based on the safety rating, we may rate Lexus as moderately safer than BMW. Then this input would add the information that Lexus should be scored higher than BMW on the criteria of safety. Once all the pairwise comparisons between the alternatives and the criteria are done, AHP can calculate a consensus weighting for all of those. The final step comes to have the AHP software arrange the total global priorities for each of the alternatives, with each alternative summing up their calculated weights across all the criteria, and then sum those up based on the proper weighting of those criteria. This could provide a final number for each of the alternatives. The higher score would indicate the vehicle is best option fitting everyone's preference described in the above factors. One may have questioned that whether people are always consistent in terms of making comparison. For example, if I say safety is more important than cost, and cost is more important than comfort, then it is expected that safety is much more important than comfort. What happens if the family inconsistently makes comfort as more important than the safety? AHP considers such potential inconsistency and will generate a consistency ratio that expresses the internal consistency of the judgments that has been entered. The final decision would only be reasonable to use if the pairwise comparison input is more consistent with each other. After using the car buying example for the AHP process, let's take a look at the team's specific problems and decisions to be made. Their goal is to identify the right privacy-friendly canonical ID to represent users, to replace the incremental numeric user IDs. Their criteria including developer experience, database support, and other factors unique to the database industry. They also listed a few alternatives like UUID and NanoID. After designing this hierarchical structure, they conducted the exercise to make pairwise comparisons, similar to the above car buying example. And eventually, the team found out that the UUID is the big winner. With clear rationale and hierarchical decision explained, this exercise allows the choice to be uncontroversial among members of the team. Now we discussed both the business problem and technical solution. Let's wrap it up. In this episode, we discussed the challenges involved in decision making, delved into a solution framework called Analytical Hierarchy Processing, or AHP, and we learned how to use it to improve collective decision-making efficiency. If you like the content of this episode, please subscribe to the channel, give me a 5-star review, and leave a comment. Your feedback is very appreciated, and I'll see you next week.